Hello viewers, this is the continuation of question 5. In the last video we had this problem where we had a 3 kilogram block sitting on a table and a 7 kilogram object whose weight was trying to pull that 3 kilogram block off the table. And we found that the acceleration is 5.98 meters per second squared. And what you see at the moment is a tug of war between left hand versus right hand. But we're not really interested in who's winning. What we're interested in is the role that the string is playing in the situation. So the right hand is pulling the left hand to the right, and at the same time the left hand is pulling the right hand to the left. Now, Newton's third law says that the size of those two forces must be the same. So what's going on in that rope? It's got a force from the right hand pulling to the right and a force due to the left hand pulling to the left, both of which are the same size, and therefore there is at the same time a force pulling in both directions in the rope. So the tension is simultaneously pulling in both directions. And that means that if we consider the system as a whole, the tension force would cancel itself out. So we would not be able to find the tension by considering the whole system. We would have to consider the forces only acting on one hand or only acting on the other hand, but certainly not the forces acting on both at the same time. Similarly, here we have a 3 kilogram block who's going to make a tension force that's pulling the 7 kilogram object back upwards, so it's going to be pulling to the left for the horizontal part of the string and upwards for the vertical part of the string. And at the same time, the 7 kilogram block is going to be pulling in the opposite direction. Now, Newton's third law says that those two forces must be the same but in opposite directions. The force from the 7 kilogram on the 3 kilogram must be equal and opposite to the force of the 3 kilogram on the 7 kilogram. So that means that the tension in both directions is the same. Considering the system as a whole, tension would cancel itself out. But if we only consider the 3 kilogram mass, so let's look at what forces are acting on the 3 kg. So what we've got here is a 3 kg mass, friction is pulling backwards, and the tension is pulling forwards. Let's take the right to be the positive direction, and Newton's second law says the mass times the acceleration are the forces pulling to the right, which we've taken to be the positive direction, minus forces acting to the left. Mass times acceleration is force acting to the right is the tension, minus forces acting to the left would be the force due to friction. So if we rearrange that equation, we get tension is mass times acceleration plus the force due to friction. Mass times acceleration, we're looking at the 3 kilogram block, and we found already that the acceleration is 5.98 plus force due to friction, which is going to be coefficient of friction is 0.3 times the normal force, which is normal force is mg, so 3 times 9.81, and if we calculate that we get 26.8 newtons. Now, if we consider the forces that are only acting on a 7 kilogram mass, we should reach the same conclusion, a tension of 26.8 newtons. So let's do that. So we've considered only the forces acting on the 3 kilogram mass. We are now going to consider the forces only acting on the 7 kilogram mass. So it's going to be pulled upwards by tension, and it's going to be pulled downwards by by its weight, which is mg. Okay, so let's take for this part of the problem the 7 kilogram mass upwards to be the positive direction. Newton's second law says mass times acceleration is therefore forces upwards minus forces downwards. Mass times acceleration is forces upwards of the tension, and we've got forces downwards are the mass times gravity. So therefore, rearranging that equation, we get T equals mass times acceleration plus mass times gravity. So this is going to be, the mass is 7 kilograms times 5.98, but it's accelerating downwards, accelerating in the negative direction, so that needs to be a negative acceleration of 5.98. Here for the 3 kilogram mass it was positive because it was accelerating to the right. Whole thing is being pulled round that way. So that means that the 7 kilogram mass is accelerating downwards and the 3 kilogram mass is accelerating to the right. That one was accelerating in its positive direction, this one is accelerating in its negative direction. We said upwards is positive. Plus the mass is 7 multiplied by gravity is 9.81, and if we calculate that we also get 26.8 newtons. Perfect. Thanks for watching. Over and out.